Today we're going to look at section 7.4. Our objective today is we are going to apply properties of regular polygons. So let's talk about equilateral, equiangular, and regular polygons. We've seen the word equilateral and equiangular before. We've seen that when we were talking about triangles. Remember, in equilateral, in this case, we've talked about equilateral triangles, all sides are congruent. That's going to be the same with polygons. No matter how many sides a polygon has, we would call it equilateral if all the sides are congruent. Equiangular would be when all the angles are congruent. Once again, equiangular triangles, we've talked about in the past, doesn't just have to be a triangle anymore. Any type of polygon, if all the angles are congruent, we would call it equiangular. So, putting those two concepts together, we would call a polygon regular if the polygon is both equilateral and equiangular. All right, so let's take a look at these pictures. Let's determine whether the polygon is equilateral, equiangular, or neither. So if I look at the picture on the far left, I see angles are marked. Now, that means that we would be talking potentially equiangular, but we need all of the angles marked the same. Notice that 2 of the angles are marked the same and another 2 angles are marked the same, but not all 4. So this one, because no sides are marked, would have to be neither. If I look at the middle figure, I see that there are some sides marked. Notice that every single side has 1 tick mark. So yes, I would call this then equilateral. On the far right, I see that we've got both sides and angles marked up. Notice the sides, though, not all of them are marked the same. All of the angles, though, happen to be marked as right angles. So this is definitely equiangular. Okay, so now the question is, are these regular polygons? So going back to the figure that we just talked about saying was equiangular, because not all of the sides are marked the same, we could not call that regular. So the answer for this far left one would be no, it's not a regular polygon. If I look at the picture in the middle, all of the sides are marked the same. I need to have equilateral in order to be a regular polygon. And then the angles are all marked. However, they are not all marked the same. We have 2 sets of different congruent angles. So because it's not also equiangular, this one is also not regular. But if I look at the picture on the far right, all of the sides are marked the same with 1 tick mark. All of the angles are marked the same with the same marking. So this is both equilateral and equiangular. So yes, this last one I would call regular. Notice that there are 5 sides. We know that a 5-sided figure is called a pentagon. So in this case, not only is it regular, we would call this then a regular pentagon. So we throw the word regular in front if all of the sides and all of the angles are congruent. All right, so talking about regular polygons, let's focus on angle 1. It says, how do you find the measure of angle 1? Well, if I know that this is a regular polygon, which notice that there's 5 sides, so this one is also a regular pentagon, we know that specifically if we want to find angle 1, we know that all of the angles inside are congruent, because that's one of the characteristics that makes it regular. So if I know that all the sides or all the angles are congruent, and I know that it is a pentagon in this case, remember the sum of the interior angles is us taking n minus 2 times 180. I know how many sides there are. So 5 minus 2 times 180 tells us that 3 times 180, or 540, is what all of those angles are going to add up to. Notice that because all of those angles are congruent, I can take the sum of all the angles and I can divide it by 5, and that tells me what each angle inside that pentagon are going to be. So it looks like each of those angles are 108 degrees. So 108, 108. Notice that specifically over here, 108. Well, there's a relationship between my interior and exterior angle. They are supplementary. So to find the measure of angle 1, I can take 180 minus 108. So 180 minus 108 tells us that angle 1 is a 72-degree angle. Okay, so that's one way for us to find the measure of angle 1. The measure of angle 1 of each exterior angle can be us finding the sum of all of the angles, dividing by the number of angles, and subtracting that number from 180. There is another way though. Because I know that my interior angle and exterior angle are supplementary, if every interior angle is 108, that means every exterior angle is going to be the same as well. So if I was to keep extending the sides, notice that all of these angles out here that I have question marks for, they're all going to be congruent. So if I marked angle 1 like this, so is this angle, so is this angle, so is this angle, so is this angle. There's another relationship that we've talked about in the past dealing with exterior angles. Remember, no matter how many sides you have, every exterior angle, when you add them up, add up to 360. Because I know in this case that all the angles are congruent, 360 divided by how many congruent angles we have will also get me that result. So notice that the measure of angle 1, I could take 360, I could divide that by 5. Notice that 360 divided by 5 is also 72 degrees. So we've got two different ways to find angle 1. So that's where these two formulas come from then. So the measure E of each exterior angle of an equiangular polygon, or essentially a regular polygon, given n number of sides, would be taking 360 divided by n. Or we could, once again, find the sum of all of the angles and divide it by that number of angles and then subtract it from 180. Okay, so remember, the interior angles and exterior angles are always going to be supplementary. So let's look at some examples. It says, how many degrees are there in each exterior angle of an equiangular hexagon? Okay, so they're telling us a hexagon, which means we should know how many sides there are. And how many sides there are is also how many angles there are. A hexagon would be 6. So if we're talking about exterior angles, remember the formula, each exterior angle is us taking 360 and dividing by n, because remember, all of the angles add up to 360 for exterior, and in this case, there are 6 exterior angles. So my answer would be us taking 360 and dividing by 6. So it looks like there are 60 degrees in each exterior angle of a regular hexagon. So here's my next example. If each exterior angle of a polygon is 18, how many sides does the polygon have? Okay, how many sides means that I do not know what n is. What they are giving me, they're giving me a number that's representing each exterior angle. So once again, exterior angles, as long as we have a regular polygon, okay, and so notice that they're saying the word each exterior angle is this amount. So if each angle that's exterior is the same, then we automatically know that it's a regular polygon. So we're using that idea that 360 divided by n gets you that exterior angle. So this is a working backwards problem. I'm taking 18 and I'm substituting it in for E. So 18 is going to equal 360 divided by n. I have to get rid of division. So in order to get rid of division, I'm going to multiply by whatever's being divided. So since n is being divided, I'm going to multiply both sides by n. N times 18 is 18n. That equals 360. So notice now to get n by itself, I'm going to divide both sides then by 18. And so 360 divided by 18 gives us 20. And it asks how many sides does the polygon have? It's not asking us to name the polygon, so us solving for n is our answer. There are 20 sides. Okay, so in this case, if each angle of a polygon is 108 degrees, how many sides does it have? All right, so if each angle of a polygon is 108, that means that each angle is going to be this, but it's interior. Okay, so this is each interior angle. And because we're talking about each of them being that measure, that means we're dealing with a regular polygon. Okay, remember, I don't know how many sides, so n is unknown to us. We got to figure that out. Well, when we're talking interior angles, in the past, we've always talked about the sum of interior angles being n minus 2 times 180. That's not going to quite help us out in this problem, though, because I don't know what n is, and I don't know what the sum is. I just know that each of them is 108, but I don't know how many times I would have to add that to get the sum. So remember, there's a relationship between interior and exterior angles. If 108 is my interior angle, I know that my exterior angle is us taking 180 minus that amount. Okay, so remember, interior and exterior angles are supplementary as long as they're right next to each other. Okay, so notice that when I subtract, I get 72 degrees. So that's what each exterior angle is. So now I can figure out the number of sides because I can use the formula that E equals 360 divided by N. I know what E is. So 72 is going to equal 360 divided by N. So just like our last problem, I have to multiply both sides by N to get rid of that division. 72n is going to equal 360. And so then I'll divide by 72 to figure out that n is going to be 8. Oh, no, sorry, 5. So it's just asking how many sides does it have. It's not asking for us to name it. So we found that n equals 5, and that's my answer. All right, in this case, it says find the measure of each angle of a regular octagon. So each angle, meaning if it doesn't say the word exterior, we're looking to find each interior angle. Okay, so if they're telling us that we have a regular octagon, well, an octagon is 8 sides. Regular means that all of the sides are the same, which means that all of the angles are the same. So because I know how many sides we have, and we're talking about interior angles, I can find the sum of those interior angles by using our formula n minus 2 times 180. So the sum of my interior angles is 8 minus 2 times 180. 8 minus 2 is 6. 6 times 180 is going to get us 1,080. But now that's what all of the angles add up to. I want to find each of those angles. So because there are 8 angles, what I can do is take the sum and divide by the amount of angles that we have. So when I divide by 8, that tells me that each angle that is interior in a regular octagon will be 135 degrees. All right, sometimes we can deal with working backwards problem in relationships to this chart here. Okay, so when it says number of sides or vertices, that means that we're talking about n, okay? So I want to find n to identify the number of sides or vertices. Remember, our formula for the number of diagonals would be n times n minus 3 divided by 2. If we're talking about interior angle sum, then that's n minus 2 times 180. Exterior angle sum, remember, is just a number. It's 360. So right off the bat, I already can fill in this part of the chart. That's 360. That's never going to change. Okay, if we have a regular angle, then regular polygon, then each interior angle, there's two different ways to look at it, but probably the easiest way would be thinking supplementary angles. So my exterior angle I get by taking 360 divided by n, so 180 minus that. So that's this formula over here. If I have a regular polygon, each exterior angle is 360 divided by n. Okay, so notice that they are giving us a 165-degree angle as each interior angle of a regular polygon. We have to figure out what the number of sides is, the number of diagonals, the sum of my interior angles, and my exterior angle. So out of all of this, the exterior angle is going to be the easiest one to find because once again, these two columns, they have a relationship. These two are supplementary. So if I know that this is 165, I can very easily subtract that from 180 and I'll get the measure that I'm looking for. So that tells me that my exterior angles are each 15 degrees. So now I only have to find out what is n, what is the number of diagonals, and what's the sum of the interior angles. Well, diagonals and sum of interior angles, we're not going to be able to do anything until I know what n is. So now we should focus on finding n. The fastest and easiest formula to help us out there, because I know my 15 degrees is each exterior angle, I can think about working backwards. Remember, if we know that each exterior angle is 360 divided by n, if I know that 15 is each exterior angle, I can set up this formula right here, where then I can work backwards and solve for n. So once again, I would multiply both sides by n to get rid of that denominator. 15n equals 360. I'll divide both sides by 15. So that tells me that I am dealing with 24 sides. So n equals 24. And now that I know that, I can very easily plug that into the other two columns where I have the formula. So we'll do 24 times 24 minus 3, all divided by 2. Well, 24 divided by, or minus 3 is 21. 24 times 21 is 504. When I divide that by 2, turns out there are 252 diagonals. When I plug 24 into my formula to find the sum of the interior angles, 24 minus 2 is 22. That gets multiplied by 180. So that tells me there are 3,960 degrees that all 24 of those angles are going to add up to. And that'd be all my answers. So if you're given one of those columns, you can then work backwards to solve for n right away. So then you can substitute them in to find the other remaining columns. Okay, so that's us applying properties of regular polygons.